When you multiply two matrices, the first thing you have to check is their size. Matrix A in this example is a 2 by 2. Matrix B in this example is a 2 by 3. So remember, when we multiply, we're going to take a row like 2, 5 and multiply it by the numbers in the columns like 0, 7. So if there aren't the same number of numbers in the row as there are number of numbers in the column, then you can't do it. So the numbers that you have to look at in the size are the number of columns in the first one and the number of rows in the second one. If these numbers don't match, you cannot multiply the two matrices. Now, when we multiply A times B here, what we're going to what we're going to end up with is a 2 by 3. And you can tell that by looking at the outside numbers. The reason we're going to get a 2 by 3 is because we're going to be multiplying 2 rows times 3 columns. So we're going to end up with 6 total answers. So I'm going to go ahead and make 6 spots. Again, it's going to end up being a 2 by 3, 2 rows of 3 numbers. I'm going to make these 6 spots, and I'm going to write out all the multiplications that have to occur. So to get the top left corner, as in the first row and first column, I'm going to multiply the first row times the first column. So 2, 5 times 0, 7. So 2 times 0 and 5 times 7. So we'll simplify over here. So that first spot will be 12 plus 0, which is 12. To get the next spot, which is in the middle column, we're going to multiply by the middle column. So 2 times negative 1 and 5 times 6. So that is 30 minus 2, so 28. And to get the last column, 2, 5 times 4, 2, 2 times 4, and 5 times 2. 10 and 8 is 18. All right, and now we're moving on to the bottom row. So now we're going to actually use the bottom row of the first matrix. Now we're doing 1, 3 times all 3 columns. It's very much like distribution. You just multiply times each set. So 1 times 0 and 3 times 7. 1 times negative 1 and 3 times 6. And 1 times 4 and 3 times 2. So the bottom row will be 21, 17, and 10. So here's some more examples. We'll look at what we can and can't multiply. A is a 1 by 2, it has 1 row with 2 columns. B is a 2 by 3, and C is a 3 by 2. So which of these matrices can we actually multiply? Well, we can multiply A times B because this 2 matches that 2. We cannot multiply A times C because this 2 does not match that 3. If I try to take the 5 and 1 and turn it sideways to match this column over here, 2, 6, 10, there wouldn't be enough numbers. We can multiply B times C because the 3 here matches the 3 there. So real quickly, I'll show you what that looks like. So B times C, if I do that, I will end up with a 2 by 2 as my answer because I'm going to take these 2 rows times those 2 columns. So I will have 2 by 2. So we're going to do 1 times 1, 2, 3 times 2, 6, 10. So 2 and 12 is 14, and 30 is 44. And then 1, 2, 3 times 4, 8, 12. I should have picked smaller numbers. 4 and 16 is 20, and 36 is 56. If I get one of these wrong, whatever. And then we're going to go 4, 5, 6 times 2, 6, 8. So 4 times 2 is 8, 5 times 6 is 30, and that makes 38, and then another 60 would be what, like 98? And then whatever we get for this last one is whatever. We're taking 4, 5, 6 times 4, 8, 12. So now, what is the point of this? Why are we multiplying like this? Well, I am going to give you a problem to consider. What if I had some triangle matrix that was like, let's just say we'll just use the 1, 2, 3, 4, 5, 6. So again, it's got 3 columns of pairs. Remember, the top row is the x's and the bottom row is the y's. So now, what if I took that matrix and I multiplied it by the matrix 1, 0, 0, negative 1? If we work that out, we're multiplying a 2 by 2 times a 2 by 3. And so the answer we're going to get is a 2 by 3. I'm taking 2 rows times 3 columns. So 1, 2, 3, 1, 2, 3. So 1, you can see the answer stays the same as our second triangle, or our second matrix here that represents a triangle. That's really important. Now if we actually multiply it out, 1, 0 times 1, 4, the 0 just makes the 4 cancel. So we end up with just 1. And then we do 1, 0 times 2, 5. Oh, once again, just the 1 times 2 is our answer. And then 1, 0 times 3, 6. And you see that we just get 3. So the top row stayed the same. Now, what's going to happen to the bottom row? When I do 0, negative 1 times 1, 4. 0 times 1, that makes that 1 just get canceled. But then I go negative 1 times 4, and I get negative 4. And then the same thing with the second column, I'm going to get negative 5. And with the third column, negative 6. So what's happened to our triangle? We went from this to this, 1, 1, 4 to 1, negative 4, 2, 5 to 2, negative 5, 3, 6 to 3, negative 6. If you think about what happens, we started with x's and y's, now we've got x's and negative y's. What happened to that graph if the y's went from positive to negative? That is one of our 3 transformations. I want you to think about which kind of transformation occurred there.